Hey everyone, welcome back to Coding with Avinash. Today we are diving into one of the most powerful tools in the world for data streaming, which is Kafka. Now you might be wondering what exactly is Kafka and why is it so important and why am I giving this huge introduction to it, right? Well, let's break it down through. So, just to make you more clear or just to help you understand, so just imagine you are at a very busy airport, okay? And like something in India, something like a Bangalore or Delhi airport, okay? And there are like thousands of flights which are arriving and departing every minute. I think you guys are aware of this something called control towers, right? Which will be present at, near to the airport, where we also call it as ATC. Now just imagine this Kafka is nothing but a control tower which manages all these flights, except in this case instead of flights you can imagine this as data streams coming from various sources. Okay, so I think now you got a very rough idea what is Kafka doing. It's nothing but it's managing the data streams which is coming through, and it distributes a streaming platform. It's a distributed streaming platform. Okay, so now let's see how does Kafka work at its core. Like Kafka, it's a distributed streaming platform. You know that allows you to publish messages, subscribe to topics, and process this stream of records. Don't worry about all these jargons like publish, subscribe, topics, and all. We will be slowly breaking. We'll be slowly going through them. Let's go through them. Okay. So as it was said, as I said before, as I just said, like Apache Kafka is a distributed event streaming platform. So it is useful to stream the events using a pub/sub model, which is nothing but a publisher subscriber model. Okay, it's actually developed by LinkedIn. It's used to, as said, like it's used to handle high throughput, and it's a fault tolerant messaging at this scale. And this Kafka is written using Scala and Java. Okay, let me just erase this and let's go to the next slide. So these are nothing but again these are different parts or parts of the Kafka, you can say, where as we just discussed before, we do have producer. This producer is nothing but the one which produces the messages and sends it to a topic, sends to something called a topic which is present in Kafka. And on the other end we'll be having a consumer is nothing but which subscribe to the topic which this producer sends and consumes the message from the topic. Okay, so I think now you got a rough idea. Like we do have producer on one end and consumer on one other end, and in the middle we'll be having something like cluster, which this cluster is nothing but the Apache Kafka cluster, where inside we'll be having multiple brokers, and again inside the brokers we'll be having multiple topics, and each topics will have partitions and offsets. And these consumers, you know, the ones which are present on the other side of the cluster, are divided into different groups. So we'll be understanding it a bit more like when we go through the architecture diagram, which we'll be going through in the next slide. Let me erase this before going to the next slide. Yeah, so this is our Kafka architecture. So this is nothing but the Kafka cluster which is present at the center of the architecture, and the left part of it is called producer. Okay, and this is nothing but the consumer. So a Kafka cluster is surrounded by producer and consumer on one end and other end. This, as the name suggests, is producer is nothing but the one which pushes the messages to this cluster, and the consumer is the one which pulls the messages from this cluster. Okay, so like inside Kafka cluster we will be having a zookeeper. Zookeeper is the one which manages this whole Kafka cluster, and we do have multiple brokers inside the Kafka inside our cluster, and inside brokers will be having topics. Okay, so again inside these topics we will be having partitions. So when Kafka producer pushes the message, it pushes to the topic which is present inside the broker, and we will be having different rep of this topic, meaning topic 1 can be replicated in multiple regions in multiple places, and in the same way we'll be having offsets present inside this topic, meaning like offset is something like which is used to, as a name says, right, it says like when consumer is reading from this topic, it helps consumer to understand till where it was read, meaning like if we have offset as 0, 1, 2, so that consumer reads till 1 or 2. So okay, if it stops in between and if it continues again, it will understand, okay, I read till top offset number 2, and from when I begin, I'll be beginning again from topic number 3, offset number 3. So I will be repeating it again. We'll be having a Kafka cluster, and on one side we'll be having a producer, and on the other side we'll be having a consumer, where this producer pushes the messages and the consumer consumes the messages. And when this producer pushes, it pushes to a topic, and when this consumer consumes from the topic. So ideally this is the overall architecture of Kafka, and I think we will be understanding it a bit more clear in further slides when I take you through the examples. So yeah, so let's go with examples. So for this example, let me take you to the open board. Okay, so let's see. As I said, you right. Okay, let's take this example. Like you have something called a Zomato. Okay, so Zomato or Swiggy, which you will be using for your these are the apps which you will be using to order food from the restaurants, right? So in this Zomato, just imagine there is a producer. Let me try it again. Just imagine there is a producer and there is a consumer. Okay, so in between we have a Kafka cluster. So there are different stages in your Zomato app, right? Like I can say, like you have selected a restaurant, you have ordered your dish, and you have purchased. The payment is also done. So ordering, payment, everything is done. Now you are waiting for your order to get delivered, right? In this case, so let's just mark them down. This I can say it as a producer, and this I'll be saying as a consumer, and here this is nothing but my Kafka cluster, and within these clusters I'm having brokers, and within these brokers again I'm having partitions. Sorry, I'm having topics. These topics are divided into partitions. Okay, so this is a producer, we have a consumer, we have Kafka cluster, inside which we have broker. Okay, and inside the broker we have topics, and this topics is divided into different partitions, which is nothing but the offsets. Okay, so now when producer want to send a message, it will be pushing the message to this topic. Okay, and when consumer want to consume the same message, it will be consuming from this topic. Okay, I'll extend it to topic. Okay, so as we said in the Zomato example previously, like you are waiting for your order. So if you see your app, you will be noting something called the live location of the agent who is picking up the order and who is going to deliver is updated on your app continuously. So just imagine Kafka is not there. So what happens at this time? So from the delivery agent, the trigger needs to happen to the update, something like we just imagine we have an update address or update location API. So just imagine that we don't have this Kafka. So what happens every time? The delivery agent, here the delivery agent is nothing but the producer. Let's imagine delivery agent is a producer. So this delivery agent need to update his location, meaning he need to hit this API every time. Okay, and when consumer want to know where the delivery agent is, again he need to hit this update location, or we can say something like retrieve location. Okay, there is another API which we can say as retrieve location. So this consumer need to hit our retrieve location API every time. So these I can say as a costly operations, right? Here just imagine in case of one user, you will be having like hundreds of clicks to this API and hundreds of clicks to this retrieve location as well. Just imagine in case of whole country. It will be like millions of users and millions of feeds, right? So in order to avoid this issue, we have Kafka in place. So what happens here is producer is nothing but our delivery agent. Okay, so this producer, whenever there is an update, meaning whenever the producer is whenever the delivery agent is moving to a different location, whenever there is an update, immediately updates will be published or updates will be pushed to topic. Okay, so this keeps on pushing. Okay, from producer it just keeps on pushing the messages whenever there is an update, and this consumer is subscribed to this topic. Okay, so since this consumer is subscribed to this topic, whenever there is an event happened, meaning whenever there is an update on this topic, consumer will be able to understand, okay, there is an update on this topic, so there is a change in the location, so that location will be updated. So here we need not be calling this externally or explicitly, we need not be calling this retrieve location or update location APIs. Instead this will be handled by Kafka, and the only duty of producer and consumer is to push messages to the topic whenever there is an update, and consumer is to retrieve messages from the topic whenever there is an update. So in this way we can say like Kafka is easy here, and it make lives easy in case of data. So also, in order to understand one more live example, we can say ClickBuzz app. In ClickBuzz app as well, whenever there is a change in the score, it will automatically get refreshed and you will immediately be able to see the score, right? So in a nutshell, in a nutshell, like whenever there is a huge events happening, like continuous real-time updates happening, then we will be using Kafka, and this will be very helpful. And there you have it. This is Kafka. Like in a nutshell, like from its robust architecture to its fault tolerance and scalability, you know, we can say it like a truly game changer in the world of data streaming. So whether you are building real-time analytics system or event-driven architectures or data pipelines, Kafka has got you covered. No issues, right? Well guys, that wraps up today's video. I hope you found it helpful and informative. If you did, don't forget to like, share and subscribe for more content like this. And as always, keep coding and keep learning. Until next time, happy streaming.